I want to jump right into angular acceleration. So we have, this is our table, and sometimes we write frequency and maybe even period up here. If we have frequency, multiply by 2 pi, and we've got our omega. Well, sometimes we don't want to talk about constant. Remember, these generally have to do with constant. We can use it. I always talk about that average velocity is such a dangerous thing. But now I want to talk about things that are speeding up or slowing down as they rotate. So I'm not going to worry about those anymore. I'm going to worry about, think of this. When things speed up or slow down, these were variables we used. So these are going to be the variables we're interested in now. Omega I, omega f, and alpha. That's alpha. And just like here, A equals delta V over T, alpha is equal to omega f minus omega I divided by T. This is one of the things I like about rotation is it can be a little confusing. The equation, the variables look so weird, but so many of these equations can be used by either one. So let's take a look. If we have any of these or time, if we have any of these ones, we can always find another one. I shouldn't say this. There's another, which is this, delta theta equals omega I t plus 1/2 alpha t squared. You also have omega final squared equals omega I squared plus 2 alpha delta theta. So in other words, all the equations that we had over here, we can use the same equations. This is the only one I'm really worried about right now for this class. I just want to get that sense of things speeding up and slowing down. So let's do a problem. Let's say, I don't know, a cat is chasing its tail. Cat chasing tail. I guess cats don't do that. A dog is chasing its tail. And it speeds up from 2 radians per second up to 5 radians per second in 2 seconds. Well, if we want to plug those in, we'd have omega I is 2 radians per second. Omega final is 5 radians per second. The time is 2. I don't know where to write that. I'll just write t equals 2. And then we can use that equation. It's going to be omega final minus omega initial divided by t. And so what you end up with is alpha equals 5 minus 2 over 2 equals 3 divided by 2, 1.5 radians per second squared, because that is the unit, just like we use meters per second squared for A. Radians per second squared is the unit for alpha. I haven't talked about direction. Generally, we're going to be talking about clockwise or counterclockwise as a direction. We'll talk much more about that when we get to torque. But for now, if you got a positive or a negative, we'll just assume whatever direction the omegas were is the positive direction. Again, I'm not going to try to trick you on that. We'll talk much more about that when we get to torque. So what you have, once again, is just a new variable that we use exactly the same as we used the linear variables. And it really is not that bad, so I'm going to stop now before I confuse you. I've put a page with a few rotational problems in there for calculating angular acceleration or using angular acceleration in one of these equations. So give those a shot.